Man, what are the odds that right when I start recording, they start doing yard work? A true test of these microphones. This is the Unit 3 Lesson 1 retrieval in our packet. It is on page 5. So the first thing we have to do is graph the functions on the same coordinate grid. So it gives us 2 and we have to graph them both. Unfortunately, they didn't give us an axis, so not my best, but we're gonna go with it. So we're starting at 5. Now we're kind of used to writing these like with the starting value first, but it doesn't matter which way you write it. We're starting at 5, so 1, 2, 3, 4, 5. And then this is our slope or our rate of change or our common difference, whatever you want to call it. We're gonna go up 3 each step. Now unfortunately I'm gonna run out of room here, so over 1, up 1, 2, 3 is maybe right there. Unfortunately, right where I wrote the Y. But maybe we could just go backwards to get the full idea of this line. Like if we go back a step, we're going to go down 1, 2, 3. So there. Back a step, down 1, 2, 3. So you can kind of extend the pattern backwards. And then I'm going to do a line to connect those, something like that. Okay, now g of x starts at the same spot. So if you want, you can rewrite this in the other way. But notice that this time it's -3. So we're starting in the same place at 5, but when we go forward a step, we're going down 1, 2, 3. Forward a step, down 1, 2, 3. And there's our straight line. Part B says what's similar and what's different about the graphs. Well, similar, they start in the same spot. Their starting value is 5. They both have a 3. But the main difference is that f is increasing, so adding 3, and g is decreasing, so subtracting 3. They're both linear as well. And there's probably other similarities and differences too. Feel free to add other details if you want. All right, we're going to skip number 2 and go down to number 3. It says to solve each equation for x. So as you can see here, I've got an x on both sides of the equation. This is basically like a scale. So imagine this is a scale. Maybe I'll put in a picture here of what I'm referring to. And this scale is totally balanced. If I remove something from one side, I have to remove the same thing from the other side. So I don't want this 2x here, because I only want x on one side of the equation. So I need to get rid of that x. To get rid of the x, I'm going to subtract 2x. Now subtracting 2x on the right is going to make the right side of the scale weigh less. So I need to take away the same thing from the other side. Like imagine if I had some apples on both sides of the scale and I took away 2 apples on one side, I'd have to do the same on the other side. Okay, 3x minus 2x is 1x. I'm just going to write x. You could write 1x if you want. Nothing else on this scale changed. Okay, everything else is exactly the same. So now I need to think of a number that when I subtract 5, I'm going to get -4. So let me make a number line real quick. Let's imagine what this looks like. So here's -4. I need a number that when I subtract 5, I get down to -4. So thinking backwards, 1, 2, 3, those are weird arrows, 4, 5. If I'm starting at 1, subtracting 5 from 1 would get me back to -4. So x is 1 here. Just kind of thinking backwards of what x would have to be so that I get -4. Okay, next one's a little easier. 2 to the x equals 16. So 2 raised to something gives me 16. I'm just going to do a little guess and check here. I know it's not 2 to the 2, but let's just start with that. 2 raised to the 2 is the same as 2 times 2, which is 4. So obviously that one's not right. 2 to the 3, 2 times 2 times 2, that is 8. So that didn't work either, but I have a feeling the next one will work. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. So this one is a little easier. X is 4. I'm just figuring out the number that I have to plug in for x to make the equation true.